So this is lecture number 18 of our course, subject waves and oscillation. Topic is the principle of superposition of the waves. Up till now we have discussed a single wave that is traveling through a straight string. Now what happens if two or more than two waves passes through the same region or through the same straight string? So if two waves pass through the same region, the net displacement of the medium, the net displacement of the particles of the medium would be the algebraic sum of the displacement of the two individual waves. For example, consider two waves passing through the same straight string. Let y1 of xt and y2 of xt be the displacement that string would experience if each wave traveled along. This displacement of the string when the waves overlap is then the algebraic sum y prime of xt. This is the net displacement or resultant displacement when two waves passes. So when two waves pass through the same medium or same region, their net effect or net displacement will be given by y prime of xt, that is equal to y1 of xt and plus y2 of xt. That is, overlapping waves algebraically add to produce a resultant wave. This is actually the principle of superposition, and the superimposing waves give rise to many effects like the interference. So let us discuss the interference also. What is the interference of the waves? This figure shows two waves that passes through the same string in opposite directions. One wave of larger amplitude and the other of smaller amplitude. So they maintain their own shape as they are far away. But when they pass through the same region like this, so these are the two individual waves, the dashed lines. This is the wave that is traveling to the right, means this one. And this one is the wave that is moving to the left. At this position, what happens? Both crests are at the same position, so their net effect is a large crest, that is the sum of these two crests. And beyond this region, that is, these waves will maintain their own shape like this. That is, when they pass through each other, they will have their own shape like this. This is independently moving to the left and this is independently moving to the right. So over here they superimpose on each other and the superposition gives rise to a net effect, that is an enlarged amplitude in this case. Now the interference of the waves. A point to think, if we send two waves of the same amplitude, same wavelength and same frequency in the same direction on a straight string, so what resulting wave does it predict for the string? This is a question mark. अगर हम दो वेव्स सेम टाइम पे सेम डायरेक्शन में एक ही स्ट्रेच स्ट्रिंग में पास करे तो उनका नेट इफेक्ट क्या होगा? जाहिर सी बात है हर पॉइंट पे, क्योंकि वेव सेम डायरेक्शन में पास कर रहे हैं, उनका सब कुछ फेज एक जैसा है, सो अगर फेज एक जैसा है सो नेट रिजल्ट विल बी doubling of the displacement at each and every point. The resultant wave depends on the extent to which the waves are in phase in step with respect to each other. So I say, as for the first question, I said that if the waves are in phase, the net result will be that the displacement will become double at each and every point. But in general, the wave may be moving in the same direction, they may be moving in the opposite direction in the same string, they may have the same amplitude, same wavelength, or different amplitudes as well. So what will happen? So let us discuss this general case as follows. If the wave have generally a phase difference, and generally the wave may have a phase difference, so how they will interfere? They will be superimposed. If the waves are exactly in phase, so that the peaks and valleys of the waves are exactly aligned with those of the other, they combine to double the displacement of either wave acting alone. If they are exactly out of phase means that if crest of one wave and top of the other wave arrives at a particular position, so they will cancel the effect of each other because the displacements have opposite signs. If crest of one wave arrives at a particular position, so the crest has a positive displacement, and if at the same position top of the other wave arrives, so the top has a negative displacement. So when we algebraically add these two displacements, the net effect will be either zero or will be diminished. We call this phenomena of combining waves as interference, and the waves are said to interfere. These terms refer only to the wave displacement. The travel of the wave is unaffected. That is when two waves interfere, they don't destroy each other, but only the disturbance occurs in their individual displacements. This is the net displacement appears over there. So let us consider one wave traveling along a straight string given by the equation ym sine of kx minus omega t, and another wave is shifted slightly from the first by an angle, by position or the time coordinate. So y2 of xt is equal to ym sine of kx minus omega t plus pi. These waves have the same angular frequency as we see over here, omega, that is the same frequency, angular frequency, the same wave number k, but are different by a phase constant pi, that is there is a phase difference. They also have the same amplitude ym. So they both travel in the positive x direction, as there is kx minus omega t term in both of them along the x-axis and have the same speed v. From the principle of superposition, what the principle of superposition says, that the net result or the net displacement should be the sum of the individual displacement. That is, y prime of xt is equal to y1 of xt plus y2 of xt. So our y1 of xt is ym sin of kx minus omega t, and y2 is ym sin of kx minus omega t plus pi. If we take ym as common, here is a mathematical step, that is, you take this ym as common, so these two terms remain sin of kx minus omega t plus sin of kx minus omega t plus pi. That is, there are this is the sum of two sines. For if we call this angle as alpha and this phase in the argument is beta, so we can write their equation. That is, if we have two sine angles, so their sum is sine of alpha plus sine of beta is equal to 2 sine alpha plus beta divided by 2. This the 2 in the denominator is in the argument, that is, should not be multiplied with the sign. This is in the argument of the sign. Cos of alpha minus beta by 2. So applying this relation to equation, this one, we get the net displacement will be equal to 2. This 2 is here in the relation. Ym is common, and cos of alpha plus beta, sine of alpha plus beta by 2, and cos of alpha minus beta by 2. So if we take this angle is alpha and this is beta, so this angle plus this angle then gives sine of साइन ऑफ 2kx और ये टर्म ओमेगा टी और ये भी ऐड हो जाएंगे. साइन ऑफ 2kx माइनस 2 ओमेगा टी प्लस पाई divided by whole divided by 2. So that 2 should be cancelled over here, and here it remains, and cos of alpha minus beta divided by 2. So if we subtract this angle from this one, so kx will be cancelled with kx, omega t will be cancelled with omega t, and we will be left with the pi divided by 2 term, which is this one, cos of pi by 2. As this pi is constant, it is independent of the position and time coordinate. So we can take it with the ym, with the amplitude, and this one is the oscillating term, because this is position and time dependent term. So this is the oscillatory term of the resultant wave, while this term in the bracket 2 is constant, ym is constant, and cos of pi by 2 is a constant. So this is the amplitude of the net or the resultant wave, and this sinusoidal term is the oscillatory term. So the net wave should have an amplitude 2ym cos of pi by 2. Now the special case if we take this pi is equal to 0, so cos of 0 is 1, and the net displacement or the resultant displacement is twice the individual displacement ym. This is the case that when the two waves have the same amplitude, same wavelength, same frequency, and are traveling in the same direction with zero phase constant or phase difference. So F2 sinusoidal waves of the same amplitude and same wavelength travel in the same direction along a string. They interfere to produce the resultant sinusoidal wave traveling in that direction. The resultant wave differs from the interfering waves in two aspects. That is, the resultant wave differs from the individual waves in two aspects. Number one, its phase constant is pi by 2. Its amplitude ym prime is the magnitude of the quantity in the brackets, that is 2ym cos of pi by 2. This is the amplitude of the resultant wave. So if phi is equal to 0, we discuss that case. And this is the equation for the special case when pi is 0. So y prime is equal to 2ym sin of kx minus omega t. The resultant wave is plotted in figure this. This is the case of zero phase constant. You have two waves represented by y1 of xt, the blue one, and the pink one y2 of xt. If they have zero phase difference, so their crest will be on crest, troughs will be on troughs, and as a result, the net displacement of every point will become double like this. F this pi, that is the phase constant, if the phase constant is pi radian, that is 180 degree, then what happens? The waves have this pattern. One individual wave is the blue one, and the other wave y2 is this pink one or the red one. So look at these points. One wave has a crest and the other has a drop. If we apply the principle of the superposition, so the net displacement at these locations, at all these locations, will be 0. As a result, you will have a straight line, that is, no effect will be seen. This is these two special cases, this one and this one. This is known as completely constructive interference, where the net wave has the maximum amplitude, while this situation is known as completely destructive interference, where the net displacement is 0. Now the pi may have any value in general. So if this is 2 by 3 pi radian, and this is 120 degree, I think. This is 180 divided by 3, so this is 60 multiplied by 2 is 120, if the phase difference is 120 degree or 2 by 3 pi radian, then this is the situation. One wave y1 of xt and the other is y2 of xt, they differ in phase by this amount and their situation is like this. So this interference is neither completely constructive nor completely destructive, and the resultant wave may not have crest at the points of the individual waves or drops. This is a table, phase difference and resulting interference types. So if the phase difference is 0 radian, the amplitude of the resultant waves will be 2ym, and this is the fully constructive interference. If the angle, the phase difference is 2 pi by 3 radian or 120 degree, then the net displacement, the amplitude of the resultant wave will be ym, and it is intermediate interference. And if we discussed these cases already, if the angle is pi, the phase constant is pi, then there is a completely destructive interference. This is a sample problem. Two identical sinusoidal waves moving in the same direction along a straight string interfere with each other. The amplitude ym of each wave is 9.8 millimeter and the phase difference between them is 100 degree. What is the amplitude ym of the resultant wave due to the interference, and what is the type of the interference? So this the second question, what is the type of the interference? This is neither completely constructive interference nor completely destructive interference. It is somehow intermediate interference, and the ym prime, that is the amplitude of the resultant wave, should be, as we discussed in the above discussion, that the net displacement should be 2ym cos of pi by 2, this pi, the phase difference. So cos of 50 degree multiplied by 2 multiplied by ym, this displacement, the amplitude, so that will give the resultant amplitude. This is 2ym cos of pi by 2, and that gives rise to 13 millimeter. We can tell that the interference is intermediate in two ways. The phase difference is between 0 and 180, and correspondingly the amplitude ym prime is between 0 and 2ym. Now this is the part B of the question. What phase difference in radians and wavelengths will give the resultant wave an amplitude of 4.9 millimeter? So again we use the same expression, ym prime is equal to 2ym cos of pi by 2. Now over here ym is already given, that is 9.8 millimeter, and ym prime is also given to be this. So what should be the value of the pi? So we can plug in the values in this equation and we get the pi to be this, plus minus 2.636 radian